The geocentric model of the universe has the Earth, the geo, in the middle with everything revolving around it. However, that's not really what the universe looks like. The heliocentric model, sun is helios, has the sun in the center with all of the planets revolving around the sun. Now, this doesn't mean that everything in the universe revolves around the sun. Different stars don't revolve around our sun, and we have moons and other planets have moons that do revolve around those planets, but the planets of our solar system revolve around the sun. That is the heliocentric model. As they're revolving around the sun, they go in an elliptical path. So a lot of times we think of the sun just at the center of a circle, but it's not. It's an ellipse. The sun is at one of the what are called foci. So it's at one focus of the ellipse. Essentially, it's just a circle that's a little bit squished, and the sun is closer to one side than it is to the other. So as a planet is revolving around the sun, there are times when it's closer to the sun and times when it's farther away from the sun. When planets are closer to the sun, they're moving faster, and this has to do with the fact that gravity is stronger because we're closer to the sun. So anything when it's closer to the sun is going to be moving faster. When it's farther away from the sun, it's going to move slower. The planets are at different distances from the sun, and those that are closer to the sun tend to be moving faster as well as having shorter paths to take, so they have shorter years. A year is the time it takes for a planet to complete one revolution around the sun. All of the planets that we have in our solar system can be divided into two categories. The terrestrial planets, terra means Earth, so the terrestrial planets are like Earth, in some sense anyhow. Those are Mercury, Venus, Earth, and Mars, the four planets that are closest to the sun. They tend to be very small. They're sometimes called the inner planets because they are closer to the sun, and they have a very rocky composition to them. The Jovian planets, Jovian means like Jupiter, would be Jupiter, Saturn, Uranus, and Neptune. They're a lot larger than the terrestrial planets. They're also farther away, so they're sometimes called the outer planets. And they're made up of mostly gases, so they're sometimes called the gas giants because there's so much more gas and they're so much larger than the terrestrial planets. In your reference table on page 2, you'll see the solar system data table. And it gives you a lot of information about celestial objects, just meaning stuff in space. So we've got the sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, the 8 planets, as well as Earth's moon. It gives us the mean distance from the sun. Remember, the word mean means average, so the distance from the sun does change as something's moving through that elliptical orbit. But the average distance from the sun is given here. And you'll notice that Earth's moon is listed as well, and it also gives the distance from Earth. Again, that would be the average distance from Earth down at the bottom here too. The period of revolution would be the time it takes to make one complete orbit around the sun. This is the length of the year. So you'll notice that as we get farther and farther out, the years get longer and longer and longer. The period of rotation at the equator, that's how long does it take to spin on its axis once. So that would be, the rotation is what causes day and night. So the period of rotation would be from noon on one day to noon on the next, meaning when the sun is highest in the sky for that particular object. So the sun rotates at 27 days, it makes one complete rotation. So the sun is rotating on an axis as well. Mercury takes 59 days, Venus 243 days. So it kind of looks like it's getting longer, but here we have Jupiter takes 9 hours, 50 minutes, and 30 seconds. So it's not a clear relationship between the distance from the sun and rotation like it is with the revolution. But these would all be the lengths of the day for those objects. So period of revolution would be the year. Period of rotation would be how long is the day. We also have values for eccentricities of the orbit. The eccentricity is a measure of how squished that circle is. If you have a number very, very close to 0, that means that the orbit is pretty close to a circle. The bigger that eccentricity number is, the more squished that circle is becoming. Then we have the diameter of the object, the planet or the moon or sun. The masses are all given in relation to the Earth. So these are not kilograms, but they're how many Earth's masses are there. So we can see that Mercury has a lot less mass than the Earth does, and Jupiter has a lot more mass than the Earth does. And then it also lists the density in grams per centimeter cubed.